Today we're going to be talking about linear measure. So a line segment connects two collinear endpoints with a line. So here I have segment CT. And that's my notation for a segment. Okay, notice how there's no arrows, on the edges of that. So that tells me that C is one endpoint, T is the other point. And I have A that is between C and T. Okay, so what do you notice? If this were a regular class, I'd be asking my students what they notice. Hopefully what you notice, I have a CA plus an AT equals CT. So I have one segment plus another segment equals the whole segment. And I don't know why our book doesn't call this segment addition postulate right away, but this is the segment addition postulate. So in your notes, make sure you're writing segment addition postulate, writing these words, point M is between P and Q, only if they are collinear and they add up. And then you want to make sure you have a diagram so you know what you're looking at. Okay? And again, the name of a segment. So the name of a segment is segment PQ with a little line over it. The measure of the segment, or the length of the segment, technically has no bar over it. Am I the best at writing this? No. But some geometry teachers are kind of picky on that, so I just want to make sure that if you have another picky geometry teacher at some point in your life, that you know the difference between those. So the name is with the little bar, the measure isn't. Okay, our first example here. Find XZ. Assume the figure is not drawn to scale. Okay, so we know that XY plus YZ is equal to XZ from our segment addition postulate. So XY, so 4 and 5/8 plus 2 and 1/2 is equal to what XZ is. I like to add fractions if they're in improper form. It's just how I was raised. So I have 37/8 plus 5/2. I write 5/2 so that it is the same denominator. So I multiply by 4/4, which is really like multiplying by 1. 20/8. So I get 57/8. And again, I like to deal with improper fractions, and that's inches. You know what? I'm going to leave it like that. Something to note. If I give you units, make sure you give me units back. Find LM. Assume the figure is not drawn to scale. So we know that LM plus MN is equal to LN. The two smaller segments, segment 1 plus the other segment, equals our entire segment. Okay, so start filling in what we know. LM, well, that's what we're looking for. MN is 2.6. LN is 4. So LM is 4 minus 2.6, and that ends up being 1.4 centimeters. Find the value of X if ST, if T is between S and U, ST is 7X, SU is 45, TU is 5X minus 3. First, let's draw a picture. A lot of times in geometry, you're going to have to be drawing a picture for what we're trying to do here. So I have T is between S and U. Okay, the whole segment. I like to denote that whole segment, SU is 45. By doing like these little lines so I know, hey, that's the whole thing. ST is 7x, TU is 5x minus 3. Something that you need to understand is we're doing two things here. We're finding the value of x and ST. So we know that the two smaller segments, ST plus TU equals SU. So ST is 7x, TU is 5x minus 3, that equals 45. So I have here 12x minus 3 is equal to 45. I add 3 to both sides, and that's 48. I divide. X is equal to 4. That's one of the things I had to find. I remember my geometry teacher in high school always saying, make sure you're answering the question. I also have to find ST. ST is 7x. Well, that's 7 times 4. That's 28. Okay, congruent segments. This is important. We're going to be dealing a lot with congruent segments. So make sure you have this definition in your notes. Congruent segments have the same measure. Okay, there's a couple symbols we use. This congruent symbol, so an equal sign with a little squiggly over it, that's a congruent symbol. Also, these red slashes. So these red slashes are going to tell me just by looking at the picture, hey, AB is congruent to CD. So I don't need to have those measures. And right here, AB, segment AB is congruent to segment CD. That's my actual congruence statement. Okay, and I would make sure you have everything that I have highlighted along with the diagram. This is really important, understanding how to write that. Example 4, consider the picture, list the congruent segments. Okay, so something you need to keep in mind. Anything that's marked with one slash, one little, I'll highlight them in red for you. Those segments are all congruent. So segment AB is congruent to segment DC, is congruent to segment DE. Anything that's marked with two little marks, I'll kind of write over them in blue for you, is going to be those segments are congruent. So AF, segment AF is congruent to segment FE, is congruent to segment BC. Our last example, consider the picture, name the congruent segments. So some segments are marked. So MH is congruent to AT. HT and MA, well, those segments are technically congruent, but they're not congruent. We don't know if they're congruent to MH or AT. They're just marked with a actual measure, I should say. So MA is congruent to HT. So that is your video on linear measure.